So let's quickly review some of the stuff that we did a day or two ago. This is the 3.2 guided practice, and we reviewed these various definitions. A conditional statement is a statement of the form if P, then Q, such as this statement. If it's raining, then it's cloudy. The hypothesis is P. So in the above statement, the hypothesis would be it's raining. The conclusion is Q, which in the above statement would be it's cloudy. The converse would interchange P and Q, so that we would be saying if Q, then P. And in terms of this statement, that would be saying if it's cloudy, then it's raining. I think you can tell from this example that converses are not always true, because just the fact that it's cloudy doesn't mean it's raining. But the converse is stated this way: if it is cloudy, then it's raining. And that's it. You don't say then it might be raining, then it could be raining. You simply say then it's raining. The statement may be false, but you have to state it definitely. A biconditional statement basically is a statement whose converse is true. So unlike this statement, there are statements whose converse is true. And we're going to come across a number of them a little bit later on. A biconditional statement can be written in the form either P if and only if Q. In this case, it's not true. We can't say it's raining if and only if it's cloudy, but that would be how we would phrase it if it were a biconditional statement. And this is sometimes abbreviated with an if that has two F's in it. P-I-F-F-Q. So let's go down further. Let's circle the hypothesis and box the conclusion of the given statement. After we write the statement as a conditional statement. Okay, that we first have to write it as a conditional statement. So a 30-degree angle is acute. The topic of the subject of the sentence is 30-degree angle. So the statement would be, if an angle is 30 degrees or measures 30 degrees, then it is an acute angle. So here the hypothesis is an angle is 30 degrees. We're supposed to circle that. And we're supposed to box it is an acute angle. That is the conclusion. Okay. Let's look at October has 31 days. And a pretty simple template for doing this is you can just say if it's October, then the month has 31 days. Okay, so if we're in October, if it's October, the month has 31 days. The hypothesis is it's October, and the conclusion is the month has 31 days. The last one here, a rose is red. If it's a rose, then it's red. Then it is red. Kind of a simple statement. We try not to add too many words. We try to maintain the original meaning. Here, the hypothesis is that it's a rose, and the conclusion is that it is red. Notice that none of these are biconditional statements. If we formed the converse of this first statement, we would be saying, if it is an acute angle, then the angle is 30 degrees. Well, that isn't always true, so the converse is false for that statement. The second statement would be saying in a converse, if the month has 31 days, then it's October. Well, other months have 31 days besides October, so that is not a true statement. And finally, if it's red, then it's a rose. That would be the converse of this statement. But just because it's red doesn't make it a rose. There are lots of things that are red that are not roses. So none of these statements are biconditional. Let's go to 4 through 6. What conclusion can be made? If angle A is a right angle, then the measure of angle A is equal to 90 degrees. If angle A supplements angle B, then the measure of angle A plus the measure of angle B is equal to 180 degrees. That's the definition of supplementary angles. And if M is the midpoint of DE, let's write a little sketch here. This is line segment DE, and this is M the midpoint. Then we know that M divides DE equally, so the measure of DM, which we can just write as DM, equals the measure of ME. And that is the conclusion we can make based on the definition of the midpoint. That's how we're making that conclusion. Let's go on to our back page. For the next 3 statements, write the conditional statement and the converse of the statement. Determine if each is true or false. Determine if a biconditional statement can be written, and if so, write it. If no, explain why it cannot be written. Let's look at the first one. A 100-degree angle is obtuse. Okay, so the conditional statement would be, again, our topic of the sentence is the 100-degree angle, is that if an angle measures or is 100 degrees, then the angle is obtuse. Okay, that's our conditional statement. So is that true or false? If an angle is 100 degrees, then the angle is obtuse, so that's true. The converse statement is, remember, this is the if P then Q, and so we've got to now say if Q. If the angle is obtuse, so this is now if Q then P, if the angle is obtuse, then the angle measures 100 degrees. Well, is that true? If an angle is obtuse, does it measure 100 degrees? Well, occasionally it might, but as a general statement, that's false. So that is not a true statement. Obtuse angles could measure lots of things other than 100 degrees. So if the converse is false, then we cannot write a biconditional statement, and the answer is no. And the reason why we can't write a biconditional statement is that if an angle is obtuse, it could have a measure different than 100 degrees. Okay. Let's go on to the next statement here. A right angle has a measure of 90 degrees. So our conditional statement would be, if an angle is a right angle, then the angle measures 90 degrees. Is that true or false? I hope we all agree that it's true. The converse now would look at what's coming after the then and put it after the if. So we have if the angle measures 90 degrees. Let's make that our if statement. If the angle measures 90 degrees, then, and we take what's after the if in the first statement and we put that after the then the angle is a right angle. Then the angle is a right angle. So is that true? If the angle measures 90 degrees, then the angle is a right angle. That's true, right? That's what happens if the angle measures 90 degrees. So both the original and the converse statement are both true. So can a biconditional statement be written? Yes. When you have both the conditional and the converse both true, you can then write a biconditional. So let's write it. Okay, so remember, the biconditional is P if and only if Q. And we can use the double F abbreviation, and we could write out if and only if. So P is an angle, is a right angle, if, I'm going to write this out, if and only if the angle measures 90 degrees. Okay, so that is a nice valid biconditional statement. Let's go on to the last statement in the guided practice. A midpoint divides a segment into two congruent segments. Okay, so the conditional statement would be if a midpoint divides a segment, then the segment is divided into two congruent segments, or two congruent segments. Is that true? Yes, the definition of the midpoint, right? And the converse now would be, if the segment is divided into two congruent segments, then a midpoint divides the segment. Let's write that down. So if the segment is divided into two congruent segments, then a midpoint divides the segment. Is that true? Yes. Because if a segment is divided into two congruent segments, then it has to be a midpoint that's dividing it. So because both these statements are true, a biconditional statement can be written, yes. And let's go ahead and write it. Again, it's P if and only if Q. So we can say a midpoint divides a segment. And this time I'll just use the IFF abbreviation. If and only if, that's how it's read. If and only if the segment is divided into two congruent segments. Okay, so that's a statement. A midpoint divides a segment if and only if the segment is divided into two congruent segments.